to prepare at all, so I'll improvise. But yeah, I mean, I work in an area that I'm very passionate about, so hopefully it shouldn't be hard to tell everyone what I do. As Marco mentioned, I'm currently at Nottingham Trent University, but about to move to Imperial College in week or like 10 days time for the Provost visiting position, where I will be focusing more and more on TinyML. I'm not too sure, Marco, I mean, the audience are familiar with what kind of knowledge that should
Yes. We're all working in TinyML, either in academia.
Okay, very good, very good. So what I will be focusing on, more or less, the applications of edge computing, sensing technologies, and so on. We apply these things to TinyML more recently, but I will tell you about our research, which is why we have chosen TinyML as a core technology for what we do from application point of view. So I lead the smart sensing lab at Nottingham Trent, and most of my researchers students work on projects related to sensing and the sensing at the edge, for example, or multimodal sensing to respond to end user organizations problem. Like, for example, we work with the health sector, we work with mental health or security and defense, sport, physical exercising, smart farming is one of the areas that we work with. So all of these areas require these kinds of sensing technologies. So let me tell you a little bit about our approach in my lab. We take system approach. So in a way that we don't just look at one element of the process. Like, for example, if you're working on machine learning or TinyML, you might focus a little bit in one of these building blocks, like the models and so on. But for us, we care about the data collection aspects. We've written some papers on how to collect data, how to capture data and label it in a systematic way. And how can you do the data analytics and on the edge or distributed data analytics, or whether it's TinyML to TinyML, for example, and then the intervention. So as I said, it's the system approach from data collection to the delivery of the action. Like, for example, in the case of crime prevention, if you want to detect that there's a crime about to happen, you want to issue an alert very quickly to make sure that you make a difference. So how can you do this in real time? That's what we care about, like the whole system approach. Many, I don't know if you are familiar with the digital phenotyping concept, where we try to quantify things moment by moment. So similar to that, where we try to take sensor input, quantify, for example, someone's emotion. Or someone's well-being, or someone's is scared or something like this, and then try to act on it, or environmental aspects and so on. So very often, the way we collect data, so since we talk about sensors in general, we are dealing with, like, wearable, for example. Someone wears a device, whether it's a watch or a belt or something embedded in the hat, so a human can carry the device. So we work very often on crowd sourcing concepts or citizen science, so human can carry the devices and collect data, or smartphones. So I was one of the early academics who worked on smartphones for research. So I remember when I was at Nottingham University, it wasn't something that people considered. At that time, mobile phones were very, very small. I mean, they were edge devices, but at that time we had very primitive screens. We didn't even have Bluetooth or GPS on these devices. So the first time we heard that, oh, Bluetooth is coming to mobile phones, or GPS will be embedded, because I remember that I used to use external GPS devices, create a buddy network for multiple devices, like pollution sensors and Bluetooth, GPS connected together in order to track location at the same time. And smartphones start to develop more and more, so that, the embedded intelligence start to increase, and more sensing capabilities. So our first project was using smartphones as sensors, and how to use them for sensing the environment and so on. So yeah, smartphones are very essential. The wearables could be connected, but then also we need very often fixed sensors like pollution stations that could complement our data, and portable sensors. Which could be mounted, for example, on vehicles or bicycles, or some of the things that we've done in early projects when we did mobile pollution monitoring, is that some of us looked at carrying wearables, others like mounting the devices on vehicles and so on. So it's just how or what kind of sensors, or how do you carry these sensors? And then what type of data? So let's say we sorted out the where we position the sensor, then you need to think also at the same time what type of sensors. So it depends on the application. So we consider whether it's physiological sensing or environmental sensing with continuous self-report. Self-reporting is very important as well, like in terms of labeling the data, giving valuable context-related information that might not be as good from the sensor. So it can add value. And zoning, like for example, if you split geographical space into different areas, location tracking, motion. And so these are the type of data that we deal with. But to be honest, this diagram needs updating, because these days, I mean, I created this diagram months ago, but now we have even more rich data and so on. So, like for example, you have social media, you have drone images, you have data coming from different directions and different resolutions. So we try to utilize that as much as possible. But most important thing is that when you start thinking about the data that we deal with, and very often, I mean, I tell that to the community in TinyML, that people sometimes don't think too much about data. And how to collect it or how to label it, because very often as academics, we care too much about academic publications, right? And using ready data sets or using someone else's data is the easiest way. And then optimizing these models, reducing the size of these models, which is great. But when it comes to the real world, dealing with real world data, not many people have this experience. I find many people struggle when it comes to real world applications. And very often people might be able to deal with a little, like one or two sensing modalities, but not at a broader scale. So that's why we spend a lot of time thinking about the science of data collection. That you could really do so many projects. For example, we've written a paper called label sensing, which you could look at how to collect the data in a systematic way. And we distinguish between passive data collection when the sensor is feeding the data continuously, so that the users don't need to do anything. So you have the on-body sensors, but also there's the mode where the active data collection. So like what I mentioned before, the self-report, you give the users some kind of questionnaires, tick boxes, radio buttons, and so on. They have to select, and not just that. Like for example, you need to consider if the users, if you're collecting some kind of data, and the users are sitting, you could give them some kind of questionnaire or happy faces or emojis to select from. But if they are running, and if they are swimming, for example, or if they are multitasking, how can these users make an input actively while they're doing these tasks? So again, we've written another paper on different modes of self-reporting. And for example, you could use audio to report. Or to say, like, okay, if it's about feeling or emotion, you could say, yes, I'm happy, or you could give some signals, or like using the mobile volume button while you are moving around, or you could have a clicking device and so on, or make some gestures. So this, again, that's why I call it the science of data collection, because the way that you input the data makes a difference, and it has impact on the machine learning models that you build later, because if you don't collect the right data, you have the wrong model. And this shows you like some examples of the devices like we built over the year, of the tools that we try to build. As I said, it's a combination of mobile apps, but also we build our own tools. And we built this before we even hear about TinyML or even edge computing. You know, how can you build a sensing device for children, for adults, for people with disabilities? We bring the users to our lab. For example, one of our latest papers is called "In the Hands of Users." So we brought users to the lab to design their own fidgeting tools. Fidgeting, I don't know if you've seen some of the fidgeting cubes, these little devices that you could buy. They say they are good for managing stress. So you have buttons to click and textures to play with. So we try to embed intelligence in these devices to see if we can help people with anxiety or stress to calm down by interacting with different buttons, and that the embedded intelligence attempts to understand the patterns of that kind of interaction and maybe push back and try to interact with them and calm them down. So this is work in progress, but we started working on this in terms of like the tangible user interfaces. Like, how can we utilize these devices to deliver or to support or improve someone's well-being in general? And also we had a project where we built or created some kind of wristband for again children and well-being, adding little emojis or toys on top of it. The project is also called interactive toys or tangible toys. The idea is to use a combination of edge computing and communication tools in order to enable children to feel better in schools. So yeah, that's what you see here. That that we use combination of tools to create this kind of watch. Since I mean, as I said, this is pre-prepared presentation. Normally, I introduce people to edge computing, but as you imagine, I mean, why we are using edge computing in my lab these days? Because I mean, obviously, we use lots of sensors, we use lots of Internet of Things devices, and so on, but it's getting to the point where privacy is an issue in healthcare. So many people find it very difficult to, like some sectors, very, very difficult to adopt edge computing or TinyML for health. Sorry, not TinyML, but in general, like let's say edge computing in general, or wearables, let's say, and the kind of devices that share data with external servers or cloud. So like, for example, if the device is collecting data about someone's health, or like capturing images or conversations, some people feel uncomfortable in terms of that kind of sharing. So that's why we started to think we need to do something about that. Why do we need to share all of this data? Why don't we keep the data and process it? And that's where we started to think, oh, we need to adopt more and more of the TinyML and the edge computing, and keep the data, or actually not to store data, but process it on the go where it's needed, or near where it's needed, and only give the insights and only give the alerts that is needed. So that's where we started to move towards TinyML. It wasn't by choice. It was like more forced on us because of the need of the end users, especially in healthcare. And the other reasons why we moved to edge computing and TinyML is that also we worked on a few projects where the funded projects meant to be to support us in setting up a 5G infrastructure or communication infrastructure. But as we develop these let's say projects, we realized that not all places can have connectivity. So we've dealt, for example, with large number of venues such as forests, parks, farms, or even places in developing countries where there are no enough connectivities. So the conventional, or like the traditional way of relaying the data to the server doesn't work. So we had many setups where we meant to have 5G and so on, but we We couldn't use that. So we had to adapt, we have to change the way we interact. And we felt, okay, if we do process the data on the edge, we could have some intelligence. We could communicate that intelligence between these devices without the need for bandwidth or the heavy infrastructure. Or we could use some kind of opportunistic networking mechanism. Whenever the connectivity is available, then we could relay some of the information. But you already know what edge computing is, so I'll skip this one. And yeah, normally I explain what is the difference between IoT and edge computing. And why edge computing, which I mentioned, the latency and the privacy issue. So personally, I think the privacy aspect is very, very important when it comes to edge computing and TinyML. So at the moment, we have a project that we are working on, very, very interesting in terms of smart farming. So it's really, the idea is, how can we utilize TinyML? How can we use short to medium range communication and also mobile phone, let's say, all together in one type of mashup network or multi-hop network. And the reason for that is that in farming environment, again, you don't have the bandwidth connectivity. You want to protect the animals, the livestock, and you want to communicate that with the farmer. Let's say, for example, there's no server, there's no cloud, it's in the rural area and so on, and you have large number of animals. So how can you do that using local cost technology? So TinyML and wireless technology could help with that. So that the project that we are working on has nodes of like TinyML to TinyML kind of mechanism. So this is something we are working on, that the communication, we started with the TinyML by itself, but now we try to look at the second phase. Now we're looking at how can we communicate between the TinyML to TinyML. And we use LoRaWAN. I don't know how many of you are familiar with LoRaWAN technology, but it's a great technology in order to propagate messages, send it from one place to another at a slightly longer range than Bluetooth, but we use Bluetooth as well. I mean, Bluetooth is something that I've used throughout my research career over the years. So Bluetooth is good, but it's shorter in range. So we use a mix of technologies, wireless technologies such as Bluetooth and LoRaWAN. And as you can see from the image, I mean, unfortunately, I don't have the up-to-date, it's in different presentation, but you could imagine that we have here the edges on the fences on different places around the farm. And you could see here that the animals have collars. These collars have TinyML devices on them with wireless technology, and it could communicate with the other devices. And the idea here, like, for example, if one of these animals was in trouble, fell down or something like this, it could, through the movement detection, it can detect there was a problem. It could run the algorithm, to see the general well-being of the animal. Like, there are some specific illnesses that we are considering at the moment using temperature sensors and physiology and so on. So we're working with the people who have extensive experience in animal health. But let's say we detected something, this could be relayed from one animal to another, extending the range, which then should reach the mobile phone of the farmer. Or if there is like, let's say the central farmhouse or something like this, this could be sent there. But we don't rely on the server or the centralized computing services. We try to utilize what's available in the farm, assuming there's no connectivity, assuming there is not much in terms of processing power other than the TinyML devices. So we use we try to choose the devices that interface with LoRaWAN, and this is a challenge when it comes to TinyML. Not all TinyML devices that you see in the market that have LoRaWAN interface. Raspberry Pi has some of its models that has let's say LoRaWAN companion that we could use. So we try always to look for the devices that are able to communicate with LoRaWAN, but it's a challenge sometimes. So, like what I said, smart farm is very, very interesting topic that we are tackling, and we're making progress. Our next stage will be we working with the large farms institute that is specialist in farming, Rothamsted, and our next step will be really to mount these devices on the animals, and also the communication and the TinyML to TinyML aspects. This project is related to some of my earlier work on pollution monitoring and noise monitoring. So this is something that I've done many years ago, built an app called Noise Spy to, like what I said, some of my early work in terms of phones as sensors. So the idea was to build an app that can use the phone microphone to detect the environmental sound and noise. But more recently, my PhD student here has been working on a concept called digital exposure. And the idea is to how can we understand the link between environmental factors and health. So, for example, if you collect data from the health or from wearables, and you collect data from the environment and start to feed them into machine learning algorithms or statistical analysis, for example, the regression and so on, then how can you understand the impact and what can cause or affect well-being in general. We run many experiments, for example, around specific paths around the university or the city. We've done studies around shopping areas to understand the relation between noise and heart health, for example. At the moment, we're looking at ways where we could use edge computing and TinyML in this area, and how to process the data on the go, for example, to give some kind of quick information about someone's health in relation to the environment. So it's very, very active. And also we're looking, and we're writing one bid which attempts to understand environmental aspects, environmental monitoring in farms as well. This is another project that we've been working on during COVID time to understand footfalls or like to deploy footfall technologies to count people, but also aggregate cluster people aggregation to understand people are gathering. During COVID, this was a great topic to discuss with the local city council. Our local city council, I mean, we have this close relationship with Nottingham council, and then they were interested, like, can we use edge computing technology, sensing technology, in order to see if people are gathering unlawfully, for example, or is this even an option? Like, because they don't have many people to police the people around. So it was an interesting concept to look at, and we already had people counting technologies that we were deploying in the city before COVID. So we started to think, how can we use the same technology to count people to see if they are aggregated, and use the different types of clustering techniques in order to detect if they are, not abiding by the recommended distance, for example. This was more like suggestions, but obviously we didn't put it in place. It's not an easy thing to deploy and force it on people. But it's interesting because the same concept could be adopted, for example, for other things like for entertainment or to entertainment, visitor economies, and these kind of things, like when you want to guide people to do different activities and see if they are grouping in the right way and so on. I think I mentioned this project, but I think this is a video maybe I could run just to show you fidgeting tools. Can you hear? Or you don't need to hear it because it's just music. So yeah, I mean, these are just a few photos shows you the fidgeting concepts and the tangible toys that project that we've been working on, promoting health and well-being in schools and also for people with anxiety and stress. I think I explained the tangible toys concept briefly before, but I think I will jump slightly to other slides. Well, you could see here some of the users who have visited us and who worked with us, the number of schools that we work with. The co-design aspect is very important. So whenever we develop technology, we make sure that we work with the users to co-create, they co-develop, they make an input, and we try to act on their recommendations, sometimes their carers, and sometimes the users themselves. And you can see here some of the activities in the lab. Some of the co-development aspects when we did the tangible toys, how can you, like for example, we showed them the microcontrollers that these can be used for managing interaction. We showed them number of sensors. We showed them the printers. We tried to explain it in simpler terms to their carers, to the ones who can understand what we proposing. We simplify it and let the users tell us what can work and what doesn't work. Like for example, if we propose that this technology can be worn on the wrist, or it can be worn as a necklace or something, these kind of usability issues for us, sometimes it's very difficult to make a decision what is the best way to do it. So bringing users on the to suggest these kind of scenarios is very helpful. And you could see here a number of prototypes that we built with different microcontrollers, trying to figure out what is the best for which scenario in the school or at home or older people and so on, and what kind of sensors to use. And we have here, if you could see here, the buttons. These buttons we use for labeling data. So like for example, when we collect the movement data or heart rate or the EDA, which are used for detecting stress, we try to label the data as well to allow it. So when we run the study, for example, the users label it for us, whether they're feeling okay or not. And this is on the co-design aspects as well, and so on. I'm just moving through the slides. I think so these are about peer-to-peer communications in schools, like using the toys in real life. Like how does it work in practice? If you have 2 or 3 children, one child will come to the playground, the presence of this child. So we use proximity detection very often. That the other child will see that their friend is in the playground. They will interact with each other using the fidgeting tools, especially for those who have anxiety when it comes to making to make friends and talk to other people and struggle with social isolation. And we have some kind of protocols of communications that we have developed for these kind of toys, again guided by the users and the mechanisms of how it works. I mean, if you're interested in how the Taj toys works, I'm happy to explain further. But I want to move to another topic that we also very active in. It's called social prescribing. I don't know what it's called in other countries, but the concept of social prescribing is how to provide non-medical services by health professionals. So for those, for example, who are struggling with mobility, who are struggling with this social isolation, loneliness, or like, for example, they have long-term conditions. They go to their doctors, but their doctors can't do any more with them. So they normally are referred to what is called social prescribers. Social prescribers can then support them with these non-medical services, but also they look at other aspects of their not health related issues, like for example housing and employment. So they really look at all the factors that might affect health. So social prescribing is growing in the UK, and there are many initiatives to promote health activities. So social prescribers, for example, you go to social prescribers and they refer you to swimming class or surfing. We have a scheme here in the East Midlands around Nottingham where people can be referred to these courses because they could help in terms of improving someone's health and ease the pressure on the doctors. There are many studies. It's very difficult to prove that, for example, if you are swimming, or if you are in a green area, if you are, doing leisure activities, that this impact your health. But we know it helps. But there are many researchers at the moment trying to prove this, in tangible ways. I'll skip some of those. It just gives you some kind of statistics of how the National Health Service here in the UK trying to increase the number of social prescribers and promote what is called green social prescribing, like promoting people to be out in the gardens, doing activities in gardens or in the parks, or horse riding and so on, because it's good for their health and well-being. Community gardens and so on. And then we had lots of interaction with the social prescribing community over the years, and we realized that there's a role for technology in this area, because social prescribers deal with the large amount of data on daily basis. Like what I said, it's healthcare, it's housing, it's education, and there's no efficient information system at the moment that can help in that regard, or no tools that can help in terms of self-management and self-control and keeping up with the advices that they receive and so on. So we started to think about what is the role of technology, and how can we use the technology that we utilize in our lab, again in collaboration with the community. How can we automate things, make it cost-effective, flexible, and easy communication? And if you want to this technology to be adopted by the wider community, it has to be, cheap. So we came up, and this was again a project also funded by the Department of Sport and Culture and Digital. It's called Tackle Me. And the initial idea was to help the visitor economy, to help local residents to visit their parks and so on. But step by step, we started to incorporate the health and well-being elements and started to work with health professionals. So the idea that came out at the beginning of the project is to develop a mix of technologies, let me see, IoT, edge computing, and mobile app, which can guide people around open space, normally park, green park, in order to increase physical activity so people can move around and walk more. But at the same time, they could socially interact, and they could get rewards for every time they visit some of the areas of interest. I mean, you could see here there are some like little icons. These icons refer to specific points of interests. If the users, for example, visit 10 of them, they will get some rewards. And at each point of interest, they get a challenge. You could see here, this is the IoT device with edge computing, that it has processing power. This one can do proximity detection, so it has Bluetooth, but also at the moment we're trying to upgrade it to edge computing, which can do also local processing because of the lack of the connectivity in some of these parks. So here, let me put this on full mode so you could see. Are you able to see the full screen, or?
Yes, perfect.
Yeah. So you could see here, like for example, this is Rufford Park, which is close to Sherwood Forest. I don't know if you heard, Robin Hood. Sherwood Forest is the home of Robin Hood. So we did this deployment in that area. And you could see here the path that normally our users take. You could call it a game if you like, tag in the park. And you could see here some of the areas of interest that they have to visit. Some of them have IT devices, some of them have edge, some of them have tags, NFC tags that they have to tap into. And you could see here, like, for example, some of the traces of the users, where did they walk and where did they go to. I'll go back to the other screen mode. Here you could see, for example, one of our NFC tags on the bridge. When the users are in that particular area, they have to tap that tag in order to get a point. And of course, we provided some ways for the users to download the app if they don't have it. You could see here, closely how the app looks like. So what is on the app is linked to the IoT devices, linked to the edge devices, linked to different to the NFC tags and other challenges in their way. So every time they go to somewhere, they receive different kind of challenge just to and every time they respond to that challenge, they get some kind of a reward. In some areas, we ask them questions, so educational questions: how old is this building, and so on. But the interesting challenge that we give them is that we incorporate AI as well. So in some areas, the mobile phone camera goes on, and then it asks the user to find the right sculpture in that area. If they find the right sculpture, the AI algorithm will detect whether this sculpture is the right one with a high degree of accuracy. Most of the time, we get more than 90%. And of course, we have trained these models beforehand. We collected hundreds of images from different sculptures from different areas. The idea of this particular game is to link people with their local community. So it's similar to Pokemon Go, but Pokemon Go can be played anywhere. Where for this, it has to be played for this part with these features, with these kind of sculptures and the history and everything. So we pre-design everything. And here, so what we did with Rufford Park attracted other people who wanted to work with us, and then we deployed similar kind of system called Tag for Active Lives at a mental health hospital here in Nottingham. Again, we had some tags. The idea is that in that hospital, the patients are meant to walk every day, but they find it very boring in a specific route. So they told us, how can you make it interesting? How can you make people interested in walking that route without feeling bored? You could see here that we helped them in terms of designing their own sculptures from paper mache. So it was very interesting for the users themselves to go through these kind of exercises, bond with each others, and come up with waterproofed sculptures. And we also ran some studies. We got some feedback from users, and you could see here some of their own made sculptures hidden around the hospital. This is the walk that they have to take on daily basis. And one of the things that we're trying to incorporate is that the mental health specialists can deliver therapies through the devices as well. We're also looking at developing wearables. Instead of the mobile phones, cheap ones where they can also use or do the social prescribing, the walking and the activity, receiving therapies through these little devices. We also have looked at ways where we could develop these devices for children, like they go for a birthday party or something like this, and they interact in the park. They have little devices. Maybe they use it for one time, or it's like through their membership and so on. Again, it's another way to utilize TinyML in an efficient way. And again, you could see here some of the images and so on. I think I'll try to. There are many things that we're trying to incorporate. Again, like for example, little robots. You could see here some of our edge devices on these little robots trying to rover around the park. One of the ideas that we had in mind, like instead of keeping these targets or points of interest fixed, we make it harder for people to find them. So they have to go and find these robots. We build a robot maze, for example, and places for the robots to go around. But it's again work in progress, and we even looked at incorporating some little drones to add to the gaming experience. I think the final project I want to talk about is crime prevention, something that we also very active on, working on. Also, we work with the defense and security services very often. We have an upcoming funded project specifically on defense and security using TinyML. They are very interested in this area. So what we do, we use, again, wearable. We look at violence detection through conversations. You could see here that how one of my PhD students have been building that model. What we do is like multi-level feature extraction. So for example, we have the audio, But then we extract the text. We looked at the features from the audio, but we look also the features from the text and try to figure out if there's a violence at a specific moment. And this, the aim is to incorporate it in a TinyML device, can be worn by people who are subjected to domestic abuse or to vulnerable people. We also look at proximity detection to detect, for example, if an offender is harassing a vulnerable person, and if they are in close proximity, they shouldn't be close to them, or for awareness and for safeguarding vulnerable people. We've been working with the Met Police, policing services. We looked at incorporating some of these technologies in London and London boroughs, 3 London boroughs, and so on. For example, we designed what we call like a safe poster to make people aware of their environment and so on. The list goes on and on. I think I will pause here because I could go forever in terms of the technologies that we develop. But the essence of it is as follows: is that it's not enough to build technology in isolation. For example, building a model, which is great. We need that, but how do you get the data? Who's going to use it, the usability issues of it. Again, I mean, how do you trigger something out of that device that you are building? Because at the end of the day, these TinyML devices need to be used in some situations and somehow. And the scenario itself, the use case, can dictate sometimes the make of the algorithm. So it's very, very important to consider these issues before, designing that. And unfortunately, at the moment, I haven't seen many real-world deployment when it comes to TinyML. It's very difficult. A lot of people do simulations, which fair enough. Sometimes you need to test the algorithms, but we need more and more attempts at tackling the real-world deployment in order to come up with solutions that can be deployed and utilized by end users. And I always push this idea that whatever we do, we need end user organizations to co-design, co-develop with. Otherwise, we as technologists always blame for not being engaged enough with the community and not delivering real-world. Most of the time, our solutions are in papers, but not visible to the community. Yeah, thank you very much.
Thank you very much. That was extremely interesting. There's an applause here on behalf of everyone. So let's see if someone has any questions. I do have a couple of questions. You can raise your hand. Okay, Alvaro, please. The floor is yours.
Okay, are you listening to me?
Yes.
Yeah.
Okay. Thank you, Professor Eiman, for your interesting talk about all different applications of TinyML. I have 2 specific questions. You mentioned that the relevance of privacy of data. How do you deal with the ethical board approvals for dealing with this kind of data in your projects? Because I need some tips about this.
Yeah, sure. So if I've got this right, you're asking about the ethical issues.
Yeah.
Yeah. So like what I said, this is a really big thing. And again, it's one of the design and considerations that need to be taken into account. Like I was talking to someone yesterday, they're taking photos and they're building all these nice algorithms, which is great. But we talked about when you have a human in the images, when you have this and that, I mean, how do you do this? So for me, TinyML opens the door for great opportunities for privacy preserving, which wasn't available before. And like what I mentioned before, the idea of keeping the data on the device, or not even storing the data. Like if the algorithms is just pulling raw data, processing, and then throwing it and feeding that into the other layers. You don't need really to store the data, and you don't need to communicate it with somewhere else. You could have even your own wearable, right, without internet connectivity. It can sense your health and well-being. It can give you some recommendation. And that's what some of the things that we're doing in an upcoming project with the health services, the local ones. And the idea is that many people are afraid of sharing data, especially if it's like images, like what we said, conversations or audio. TinyML can help with that big time, because again, like I could process conversations but without storing the content. So it's just telling me like there's violence coming out of this, or there's someone is dying, or someone is not well, or someone, but I don't need to know what is the content exactly. The algorithm will pull the features, will process it, but not the human. I think that's where the power of TinyML, I think, where it can help in protecting privacy, and obviously easing the ethical issues. And also the other thing that we keep talking about when it comes to ethical issues, or like, let's say, responsible AI, is that it has to be done with the users, because the end user organizations, they tell us all the time what can be done, what can't be done. In fact, from my experience, sometimes researchers are more harsh than the end users, especially when you talk to other domains. Like there are many cases where they tell us, oh, older people don't want this and this and this and this, and then when you talk to the doctor who's looking after the older people, and the older people say, oh, actually, don't give me this, I want this now, I don't care if people heard my this or that. I think hearing it from the users themselves is very important, because then we could know what they like and what they didn't like. Assuming that they don't like everything, that's not the right thing. And there might, through the interaction, you might realize actually they are okay with this, but they're not okay with this, for example. So that we do the co-design to make sure that we protect privacy and so on. But again, TinyML is big thing for privacy protection.
Okay, thank you. Thanks for your.
You're welcome.
Any other questions?
I have a question.
Sure.
You were using LoRa with cell phones. Was that an easy connection? Is that something you can just purchase?
We don't use it with the phone directly. We use it with Raspberry Pis, Raspberry Pi Zero, or, different models of Raspberry Pis. Some of them can interface with LoRaWAN. I think in terms of mobile phones, I don't think the mobile phone can connect directly to LoRaWAN. You could connect indirectly to it through Bluetooth or something, but the easiest way is really to purchase some of the variations of Raspberry Pi models. I think there are other TinyML devices that you could also use with LoRaWAN. I mean, if you're interested, I'm happy to share some links to some of the devices we use.
Also curious, your programming of the cell phones. Were you using Java? Were you using TensorFlow JS?
So I'm personally, I've been teaching mobile development for some time. I teach Android normally, so all my team use Android. We normally use Java, but over the last 2 years, we started to use Flutter very often. So Flutter, our default now platform, and we use TensorFlow Lite or whatever is available in combination with the Flutter. It depends like what kind of model is used, but sometimes. That's in terms of the mobile phones. But of course, for the TinyML, is completely different story. Yeah, but I personally like the Java a lot because it enables different types of capabilities and access to APIs and so on. But again, we migrated to Flutter, not for teaching. Teaching we still do Java, but we use Flutter because of the cross-platform capabilities. Many of the people we work with many companies who ask us to develop apps. We find it much easier to do it with Flutter and then deploy on, like for example, our game, Tag With Me and the others. It was easier to deploy on both Apple phones and iOS and Android.
Thank you very much. Really interesting topic you presented. I really enjoyed that.
You're welcome. Thank you.
I think Laila has a question.
Yes, thank you. Okay, I really enjoyed your talk. Thank you very much.
Thanks.
I want to know something maybe specific of the project in the field with the cows, with the animals, because I work on that. So maybe I can contact you later. But I want to know what distance can you reach with LoRa in the field? What kind of information are you sending using that technology, and what is the autonomy that you expect to have with this equipment?
Yeah, so I can't tell you, we are in the process preparing to deploy on cows. So maybe if I've done this presentation in a few months' time, it'll be easier to tell you. But what we did some testing on a human, like my students and researchers, they've been testing around the campus. I think you could reach a few hundred meters for the LoRa, but you can't control the range. Right. So, for example, same as a Bluetooth, sometimes you don't want the long range because you want to detect a specific range and so on. So you could control it, but LoRaWAN is on the wider range, so it can really reach for long distances in hundreds. But it depends on the makeup of the board as well. Sorry, the second question: what is what I want to do with this?
The information. The information are you
in the farm context?
Yes.
Yeah. So again, we started with building this kind of multi-hub networks. First of all, just to test, again, because of the lack of connectivity, how can we relay the message from one place and hope from one? So we proved that. We submitted paper on the second stage. We building algorithms like AI based on sensors. The next stage will be in terms of, and we are in the discussion at the moment with specialists, who work with animal health. Like, for example, we're looking for the right temperature sensors that could work for cattle and, large animals. We're looking at the physiology. How can we detect? And we are very interested. I mean, that's what they've been told, like the heat stress aspects. Like, this is very interesting in different countries. Like, how can you detect that the animal is exposed to heat stress? That's something we've been told is very interesting. Other things that we're trying to look at is like the mating patterns between animals from farmers' point of view, like when the animal is in the mating mode or they are expecting, and so on. So just to understand the animal behavior and be able to predict that this animal will be in need of this or that. But we are responding to the specialists, and there are now enormous conversations with different types of specialists. Some of them interested, as I said, like we work with zoos as well, like some of them interested in gorillas, and so I'm trying to see what everybody wants. But if you are interested, get in touch, and we could tell you more about,
Yes, of course.
the next steps.
Thank you.
Thanks for the question.
Okay, super. I have one question myself. So talking about TinyML, usually in our community, what comes out as a question from young students working on the master thesis or PhD students, they always ask, what are the new directions I should take in my research in TinyML? So do you have any advice we can share?
I could. So one this is a hot topic at the moment we're working on contextual algorithms. So for example, when you obviously with TinyML you want to reduce the size of the model, the algorithms, and the processing that you do. So instead of doing things randomly, or not randomly, but let's say you're focusing, for example, on one kind of data, solving this problem and building this model. Knowing what is the context. Like, for example, if you have multiple sensors, do you want to switch all these sensors from the beginning on and feed all of this data? That will consume lots of power. So how can you study the context first? And that's why I always talk about the applications, because understanding the application, knowing what you want to do with that. Like, for example, will you be able to deal with low resolution images as a starting point rather than the full resolution? If that can give you some support until, for example, something happened, then you switch to the higher resolution or switch the other sensors. We also building combined models in that one model can help with the context, the other model can trigger something, and so on. These models can go on and off, interacting with each other. So these are some of the things. I'm happy to collaborate with people who are interested in this area. This is something that we have a paper about to be accepted, hopefully, in this area, but we try to build on it, contextual models for TinyML. Based on what's happening, what is the scenario, switch on the models, switch on the sensors, but also maybe change the feature extraction, change the layers according to the context.
Very
but this is
interesting.
something we're working on to talk to whoever is interested. Maybe we could write paper together.
That's a very interesting and appealing call. Super. Any other questions? if there's no more questions, then thank you very much. That was a super interesting talk, and we hope to see you again for the next talk in 1 month, so we can create this TinyML, academic community and work together on such interesting, research projects.
Oh, great. I mean, I'm happy to talk to people afterwards if they have any. For the invitation, Marco. I'm sorry that I forgot about it, but hopefully in the future I will have like early reminders.
Super. Okay. Thank you very much. Thank you all, and see you next week for the show and tell.
See you. Bye-bye.
See you. Bye-bye. Bye-bye.